Pakistani ingenuity is creating miracles. They can manufacture original parts and even parts that didn't exist before. Our skilled Pakistani brothers have crafted an oil cooler to cool a diesel engine, an incredible feat that left diesel engine manufacturers speechless. This is a robust Pakistani enterprise adept at producing standard components and excelling in customizations. First, they prepare the materials needed for the cooler, cutting some square tubes as a backup. The cutting process isn't particularly challenging, but the old master insists on doing it to ensure precision. He also cuts some angle iron, and as expected from a seasoned craftsman, the materials are cut to perfection. Next, the square tube is placed into a punching mold, and a drill bit is used to create holes big enough to fit a copper tube. Despite the numerous holes required, the master doesn't use a vise for stability. His one-handed drilling is impressively steady. Once done, the square tube is removed, and the process is repeated with a second tube. After drilling, further processing is needed, countersinking the holes with a drill bit to facilitate welding. Then, using a vernier caliper, he marks out the center points on the tube, creating fixed points for drilling. The next step is to enlarge the hole for the oil pipe connector. The connector is made by attaching a screw to a rod, which is then lathed to the correct size. A nut is installed inside the pipe, secured with a rod, and welded into place. After removing the rod, the threaded connector is complete. Now it's time for assembly. 2 angle irons seal the ends of the square tube, forming a perfect rectangle. Welding ensures a tight seal at both ends. After welding, the seams are ground smooth for a flawless finish, boosting the product's quality. Any sharp corners on the angle iron are cut to a blunt angle and ground smooth, completing the cooler's framework. Next, they craft the cooling fins. Copper tubing, familiar to anyone who's installed air conditioners, is cut to size with a manual pipe cutter. Bent tubes are hammered into shape with a wooden mallet. The tools are peculiar, and one looks suspiciously like a grenade. The drill is then used to round out the copper tubes, ensuring they're perfectly circular and the edges are smooth. With the copper tubes prepared, they are carefully installed into the frame. The fragile tubes are prone to bending, so the installation is done carefully. The method involves inserting the tube into the bottom and then pulling it up. 2 iron plates are added in the middle to reinforce the copper tubes and prevent them from bending during use. The iron plates are then aligned to maintain level, and a marker marks the position to prevent shifting before the plates are welded in place. The welding of the copper tubes is crucial. The copper tubes are heated using phosphorus copper welding rods and a torch, and the rods dipped in flux are used to fill the gaps for a strong weld. The iron plates are also welded, enhancing strength. With the copper tubes welded, it's time to test the welds. A cap is placed on one end, and a wrench tightens a connector. Compressed air is then used to test the cooler for leaks. After a successful leak test, the thorough craftsman subjected the cooler to a violent test, hammering it on the ground and submerging it in water. No bubbles appeared. He then scrapes the copper tubes with a wooden stick to simulate extreme conditions, further testing the weld quality. The master's welding skills are impressive. Despite the rigorous testing, the cooler remains intact. Finally, the middle section is ground down to smooth out protruding weld points, improving the appearance. A coat of black paint is applied to the frame and the copper tubes, adding a refined finish. It's unclear if the paint will affect the cooling performance, but the final product looks fantastic. The cooler's mounting holes are customized to fit perfectly in front of the radiator, giving it an OEM look. With the cooler in place, the oil pipes are installed using standard connectors, making the process simple. Tighten the connecting screws. The other end of the oil pipe is connected in front of the oil filter, creating a seamless structure that doesn't reveal it's been modified. Of course, it undergoes a final round of testing, measuring the cylinder pressure, which checks out okay with no leaks detected. What do you think? Does this modification show real technical skill?